Hi, in this tutorial we will go over region representation. For region representation we will study three approaches: array representation, hierarchical representation, and symbolic representation. The first one, array representation, is kind of similar to what we did with the threshold, because what we have in an array, we define and structure an array that is the same size of the original image, either whether we're representing a 1D vector or a 2D array, and we're mapping each of the elements from the array, um, each of the elements of the image with um, with an alpha value in the corresponding region. Like for example, here in this figure, in the first example, you see that I have a solid circle there, and then there is a background. So the background in this case is matching ones, and the solid circle is zero. So this is kind of similar to the approach that we got with the thresholding, that we got like a binary image. Now the same like when we're extending the thresholding, here I got multiple objects and I have multiple alphas value for each one of the regions. And then here you see I got the values that I have of the regions, and then I mean it doesn't look straight, but just to get an idea, this is a matrix, right? It doesn't look like that because I was trying to match the object. So I have a circle, got a square, and then I got multiple values there. And again, these are approaches that they would be used to try to understand regions and identify objects. So something else that we can have a more complex object that can be composed of other objects. We can have like a mask, or for each pixel we got different set of values, like we're talking about the complexity. So we're placing special emphasis on the hierarchical representation, and for the hierarchical representation, that will be representing the images in different resolutions. We have pyramids and we will have quadrids. So for pyramids, we have an original image, and then we're going to represent that in reduced versions of the image or different resolutions. Like for example, the n by n is the original image, and then we have an n2 divided by 2, I mean n divided by 2 by n divided by 2, and n divided by 4, n divided by 4, and so on until we get to 1 pixel. So each one of these will be my regions in different resolutions. And let's see, we can see some examples. Like in this example, this is the original image there, and then this is different resolutions, and so on. So we got the pyramid. So this is just an example. Here I have another example of a pyramid, the original image, and then where we have the high frequency of the image, and then here you see all the different resolutions. So one possible approach here to reduce the resolution, maybe we do every 4 pixels. We average those and we create a new resolution with the average of those pixels. And then we keep making uh, the reduction, or the different resolution, until we going into I mean different type of regions in the image. Now for quadrids, we have type like a data structure. There is a tree that has three types of possible nodes, in which only one of them can have children, and the other two define one of the two possible regions. So let's go into an example. So here again, this is the representation. So we got a circle here, and then here we have, so the representation here, the original picture was a circle, and then this circle, we divide, this circle has an area here with red. So we're gonna have two regions, one that includes just white, red, and then when it's something else, red and white, that's gonna be my third node that can have children, that can further the split. So we start by splitting the original image in four, so that's what we call quad, because we divide that in fours. So this quadrant of the image you see is all white, so these have no children. We don't further divide these. The same with this area and the same with this area. So this first square or quadrant of the image as a red and white. So that will be the type of node that will further divide in other four regions. So we got divided in other four regions, and then you see this whole thing is red. So this section of the image is just red, this is just white, and this is white. They don't have children. So this section is red and white. So we're gonna further divide, and then you see the ones that are just pure white, then we don't divide those anymore. Then here these two quadrants will have red and white. We keep doing that process until each one of the quadrants, the square is either just red or just black. So this will be represented as a data structure. So this is another example. Here this is the image. Again, we start dividing that in four quadrants, so four sections, and then in here there is only one particle, one object there. Then we don't further divide. So look at how we have here match that with the tree. You see this section here, so the dot here in the structure will be the original image, and then we divide that in four quadrants. Look at these two, the blue ones represents this quadrant over here that they have no children, and then these other are further divide, and again one of those have further divisions, and until we get into the sections that are listed there. Okay, this is another nice example. Again, the original image was that airplane. Look at how this first is further divided into four sections, and then each of the four sections is further divided. You see it's either just those little squares, one of those little resolutions has to be a part of the airplane. Then you see one of those little squares has to be just white. I mean, like for example, this square over here, it has black and white, and it's gonna be further divided in four pieces, and so on until we get to the point of like we see this in this example. That is only each square contains either the 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 foreground or the background, in this case for the airplane. The other type of representation that we call symbolic representation, we link that basically with physics, with ideas of centroid momentus in the image. And in, in this class we're not going to study a lot of those, but we just need to be aware that there are other ways of representing regions. We use other non-computer science areas, and one of the best one will be physics, using examples from physics. And like I was saying before, one possible way of getting the different resolutions, like in the case of the pyramid, that we were dividing that in fours too, the same like the quadrants, is like for example here we go into all the neighbor pixels down, and then we add the resolution, and then we divide it by 4. Like for example here in the pyramid we got the n by n. Then what about if these 4 pixels in this corner, we add all those 4s and we divide it by 4, and then we get that pixel over there, right? We're changing the resolution. So that's one possible approach. So here we wanted, I mean, this is a possible example. I mean, if we don't go with a specific image, for example, this is a binary image in which I'm asking you, this binary image is just zeros and ones, in which I'm asking you to get the representation of the trees. So in this case I'm calling gray, white, and black, and you see the gray, and I haven't finished with these three, but I just started. So the gray is the one that can have children, and then there is white and black. So it's just white, here is black. So that means we find the region that we want. So here is the 1, 2, 3, 4 quadrants that we have in this example. So if this is my image that is just zeros and ones, so each one of those elements is a pixel. We divide this in 4 pieces, and then you see that, for example, this quadrant has zeros and ones, I have zeros and ones, zeros and ones. Then I need to further divide But for example, when I divide this quadrant, I have only ones here, only zeros here, and only ones here. So these three, I mean these four won't be divided, right? So I don't need to do anything else in these three, um, because this is just ones, this is just ones, and this is just zeros. So this quadrant will be represented here. I'm sorry, this will be my number two, so the number two is here. This is the number one that I'm just, I mean, the way that I'm following the example. So here again, this is just zeros. So you see these zeros goes with that square here, and then I got this ones, which is my two here. So this is just the ones will be the blacks. Then here I got a 0 1 0 1, so that will be represented by this third node, and that's the one that I'm calling here the 3. So you see when I divide this in other 4, then I got 0 1 1 1, and this is the case that I have here. So you see squares, and then for my number 4 children, for this is only ones, that will be that black, so that will be the representation of that area. So we go with the second one. I have here ones, which is black, zeros there, and then here is the ones, which are over here, and then 100. So I haven't finished with this section. So you see that this is a circle, that means this can have children, so I need to further divide this in other 4, and now these will be my third quadrant, which is this. So you need to complete this in the posting. So here I need to divide this in 4 pieces. You see here I'm gonna get ones, zeros, so I'm gonna have something there that is won't be, I mean that is, we finish, and then this other quadrant, it will go in that node.